In the last class, we have discussed up to table types. Okay. So today we'll discuss about views, materialized views related to Snowflake. Along with that, we are going to discuss the last topic, that is the data warehouse concepts. Okay. So today we'll try to complete these two as well. Okay. I'll try to complete these two. If not, like we will discuss this one tomorrow. So everybody is available tomorrow, right? So is there anyone having their any party plans tomorrow? Vikas, Sainath, Nihal, any party plans tomorrow?
No, sir.
Okay. So then I'll take class tomorrow then.
Okay.
I'll not take much time. Tomorrow I'll take only 30 minutes or 20 minutes. That's it. I'll not take much time. Coming back, let me go with the views. Okay. So what exactly mean by view? Okay. So till now we have discussed only one object, that is the table. Okay. What we are storing in the table, we are storing the data. Okay, I'm storing the data in the table. Now, we have not, so in the database, we have multiple objects, right? Okay, so like views, materialized views, procedures, like that, right? So each object will store some information. Okay, when it comes to view, view will store the query. Okay, when it comes to materialized view, it will store query and the result set. Okay, so if you go take procedure, it will store the script. Okay, each object will store some information. If you take the table, it will store the data. If you take the view, it will store the query. If you take the materialized view, it will store query press result set. If you take procedure, it will store the script. So each object will hold some information. Okay. As of now, we have done with this table part. Like we have discussed DDL, DML, DQL related this table. Okay, and how to implement all this on multiple tables. All those things we have discussed already. Now we'll discuss about this view today. Okay, view is a database object. Okay, as highlighted, all these are objects. Okay, that contain SQL query. So what it is storing? It is storing the SQL query, but over one or multiple tables. So this query, what are the query we are storing, right? That query can have multiple tables. Okay. Next, a view considered as a virtual table that can be used almost anywhere that a table can be used. Okay. So whatever the view I'm creating, right? That view can be used as a table. See what we do with the help of table. I can do joining, filtration, sorting, grouping, transformations, everything. Whatever the things I'm doing on table, right? Similar, all those things I can do on the view also. Clear? Any doubts? Okay. Now, so what we store in the view, we store the query. Whenever I call the view, right, it will trigger the underlying query, and whatever the result it is providing, right, that will be printed in the result set. Whenever you query a view, that underlying SQL query associated with the view get executed dynamically and will fetch data from underlying tables. Views serve as a variety of purpose like combining segregations and protecting the data. Okay, so how to create a view? Okay, so this is the statement for creating a view. Create view name as, and we'll write the select query. Okay, so what are the uses that while using the view? What are the uses for using the view? So there are three important uses are there. One is flexible and dynamic. Okay, whenever there is a changes happen in this table, those will be reflected in the result set. Okay. Second is hide complexity. See, assume you want to share some query with the what we call the BA guy or a product owner. Okay. Now, if you provide him a 40 lines query or 60 lines query, he get confused. Okay. Rather than exposing all the complex logic, what I do, I'll create a view on top of this join condition so that he can simply call that view and he can do sorting and he can do filtering the result set. Okay. Next, security. Okay. I can create multiple views and I can, based on their roles, I can provide the access. See, if there is a manager, I will share all the data. If there is a data analyst, I will show only few columns. If there is a student, along with the sensitive columns, I will hide a few rows as well. So I can increase the security by using these views. So view is a virtual table based on the result of query without storing the data. We use views to persist complex SQL query in database. Views are better than CTE, improve reusability in multiple queries. So what happening in the CTE? I cannot call that temporary result set outside the query, right? But here I can use this view anywhere in the database. Okay, views are better than table because flexible and easy to maintain. Okay, next, store central complex business logic, hide complexity, data security, flexible and dynamic, offer your object in multiple languages, virtual table in data warehouse. Okay, so in Snowflake, we have three type of views. One is normal view, second one is secure view, and third one is materialized view. So today we will discuss all these three. Okay, let me go with the normal view. Okay, so let me go to my Snowflake account. Okay, there is a table called product. Okay, let me execute this product. See, now I'll create a view on top of this. Let me create a view. Create view, view name. Let me create a VWD prod as select star from products. Okay. Now, whenever I call this view, select star from view, what will happen? It will execute this underlying query. Okay, whatever the result we'll get from by executing this underlying query, that will get printed. So if you are execute view, what it will do? It will execute the underlying query. Okay, so what are the benefits? First one is flexible and dynamic. See, if I add some record into this product table, okay, those values will automatically reflected in this view. Okay, let me insert some values. Insert into products. Okay, values. I have inserted one record. Now, if I execute this view, right, you can see the that particular record, whatever the thing I have inserted, right? So that you can see here. This is the record I have inserted. Okay. Uh, so this is the one thing. Okay. Next, hide complex logic. Okay. I can create view on multiple tables. Let me create one view on multiple tables. Create view. Let me view prod sale. Okay. As select A dot star, comma, B dot star from products. A inner join sales B on A dot product ID equal to B dot product ID. Okay, I can create view on multiple tables. Okay, now why are these happening? Say inner join sales B on A dot product duplicate column name. You got it. So let me put here select star from, or one thing I'll do, let me write this one, star exclude b dot product id expected. So in Snowflake, we have a function called exclude. By using that function, we can exclude few columns from the star. Okay. So everything I have written correct only. Let me execute this one again.
Actually, B dot exclude you mentioned.
Okay, just exclude product ID. Okay,
Yeah.
got it. Now I have created this view. Okay. Select star from, right? So now I can share this table with the product owner or BA guy so that he can easily filter these details, sort the details, and he can do some advanced analytics aggregations. Rather than applying on these multiple tables, right? He can apply on this simple view. So hide complexity under this thing. So we already discussed flexible and dynamic. Whenever data changes happen in the product, that will be reflected in this view. When it comes to second point, okay, hide complex logics, and the third one is security. Okay, let me create a table. Okay, let me create a view, same like this. I don't want to expose all my product details. I want to only share the category furniture. Okay, now what I'll do, rather than sharing all the columns or all the rows, what I'll share the limited rows, whatever the that particular person required. Okay, so let me create this view. Now you can see that he can access only limited rows, not all the rows. So I can increase the security. I can change the column names or I can change the table name also. So security will get increased. Getting it right? Create or replace. I don't want to expose all the columns. Okay, I want to expose only limited columns. So product ID as PID, comma, product name as p name, like that. Okay, price as some am. Okay, like that. I can increase the security of the table. So now my column names and my table name is not exposing here. So I'm increasing the security also. Getting it? So by using view, I can, so these views are flexible and dynamic. Second, hide complexity. Third, I can increase the security by hiding the rows and columns, and these column names also I can rename it with the help of this alias concept so that that column names will not get exposed. Okay. When it comes to Snowflake, I have two type of views. One is normal view. Second one is secure view. So what is this secure view? Let me create a secure view. Same. Okay. So here I'm using keyword called secure. Now let me execute this one. Okay. Hmm. Let me create a user Snowflake user creation with password. So here to create a user, create user username, user that name, password, and all those things. So here the password and all those things will provide. But I don't require all these things. I just need a create user username, just password, login name. That's it. Create user username. Let me create a user called Pawan with a password. Let me give password as 12345 6. Okay. Login name. Let me put as Pawan. So this should be false. I don't explicitly define this as a human user. Okay. Okay, I'll explain this one in the, there is a concept called Reback, DAC, all those things. I'll explain this creating user in that, what we call the role management, access control and role management. Okay, what I want to show you is like how the secure view will help in the real time. So that is the thing I want to highlight. Okay, here the password must have 12, 14 characters. Okay, must change password. True means he, while login, right, first time, you need to change this password. Okay, let me create this one that created Control Shift N. Let me copy my company URL. Done. Let me log in with this new user and password. That login name is Pawan. The password is this one. So now it will ask to change my password. Okay, now you see I cannot access anything. Okay, whenever I create the user will have just account level access. He cannot access any of the objects. Okay, now let me go to my SQL sheet. You can see there will be, I cannot access any databases available in related to this particular account. Okay, so these are the Snowflake sample databases. It's not real databases. Okay, I cannot access anything. Now let me provide him the access. Okay, so how I can provide by using alter command, alter user one, add, okay, let me go with ChatGPT. So I'll get two commands. One is for database access, another one is schema access. Okay, okay. So got it. So here so here it created the role. Okay, I can give direct access to that user, but here it has given role. Okay, I provided this database access and schema access to this developer role, and I'm assigning this role to the Pawan. Okay, now let me refresh this page. Okay, now you can see this database I can access. Okay, now let me go to catalog here. Okay, even though I got access on this particular database, right? I cannot access any of the objects under this DWH. I need to provide that object access also. So grant usage on, let me provide access on this view. So what is the view name we have created?
Secure view
Mm,
something.
so this is the one, right? Secure view VW broadcat to role developer. Okay, so now I got the view axis. Now let me refresh here. Okay, now if you go here inside this one, right, I cannot see the script. Okay, so what is the difference between normal view and a secure view? So the main difference is, okay, in the normal view, okay, in the normal view, the query will be exposed. Okay, here I have multiple, right? So if you take this VW prod, okay, this query will get exposed. If you take the secure view, this query cannot get exposed except whoever created this view. So only those person can access this, then only that person can only view that particular view. Okay, let me add this one also so that it will become easy for you. Let me give one more view axis. VW prod. Okay, now let me refresh. So if you see here, I can view the normal view. Okay, I can see the underlying query related to normal view, but I cannot see the query related to secure view. Okay, so let me execute this query, show views. Okay, so if you see here, how we get to know whether this is secure or not with the help of this column. Is secure false means it's a normal view. Is secure is true means it's a secure view. Okay, so if anyone, we create a secure view, that query, except the person who created that particular query, right? Except that person, nobody can access that, cannot view the columns related to that particular view. Okay, that is the difference between normal view and the secure view. So, any doubts? Any doubts? Anyone? Up to here? Okay. So, the last one is materialized view. The last one is materialized view. Okay. In the materialized view, what will happen? Okay. Materialized view will store both query as well as the result set by executing that query. Okay, so what it is storing, it's a hybrid of this table and this is a hybrid of this table and view. Okay, it will store both the data as well as it will store the query. It's a hybrid, like both. It acts like both as a table as well as view. Okay, so when we use view, when I use materialized view in the real time, okay, I'll tell you. Okay, assume this is my Snowflake account. Okay, and this is some data mart. Assume it's a Postgres. Okay, this is Postgres. Now, if I want to transform the data from this data warehouse to data mart, then I use views. Okay, so rather than creating separate database, if I want to use okay, this data mart inside the Snowflake, then I create materialized view. Why? Because in I can okay, why I cannot use materialized view for transforming the data? Because materialized view can be created only on single table. Materialized view can be created on only on single table. That is the reason you cannot use this materialized view for data transaction. So I want to, so what exactly mean by data mart? In the data mart, we use a concept called denormalization, which means I join multiple tables and I will insert into the data mart. But here materialized view you cannot apply joins on top on materialized view. That is the reason for data transformations we use views. For data mart, okay, inside the current database, then I go with the materialized view. Okay, getting it right? Any?
Sorry, once again, go that.
Okay, I'll explain this in the next slide. Okay, you will get some idea. So let me go with the slide. So normal views are primarily used for simple complex queries and provide clean and conceptual layer of data. So these secure views are specifically designed for data privacy and are essential for compliance on heavy environment. Okay. So when we use normal and when we use secure, I have given, just go with this one. Materialized view can be thought as a hybrid between table and view. Just like a view, it has a query associated with it, and likely table it stores the data physically. When we create materialized view on a table, that materialized view is populated by the select statement provided by the create materialized view. Okay, so it's similar to view, but here what is happening? Okay, here I'm creating materialized view, right? So whenever I execute this materialized view by using select star from materialized view, then what it will do? It will load the data from this table. It will load the data from the main table. Okay, now whenever the data changes happen, right? Whenever the changes happen in this table, those will get automatically loaded into the materializer view. Okay, when it comes to view, whenever I'm loading the data, right, it will execute the query and whatever the data is there in the table, that will get loaded. But when I'm calling select star from materializer view, this materializer view will store the data. So I will get result set from here. If I call view, I'll get data from table. So that is the reason difference between view and materialized view. Okay, again I'm repeating. When I execute view, it execute the underlying query, nothing but it will fetch the data from the table. When I execute materialized view, if it is a first time, it will load all the data into the materialized view. Then it will print the result set from this materialized view. Okay, so now where I'm getting the data? I'm getting the data from materialized view, not from the table. Whenever the data changes happen here, that will get loaded automatically into the materialized view. Clear? Any doubts?
This materialized view results will be storing in the cache or
Storage layer.
storage.
Storage layer only. It's not
Okay.
in cache. It will be stored in the storage layer.
Okay.
Okay. No need to refresh data manually. Snowflake perform automatic background maintenance of materialized view. Whenever base table changes, Snowflake run background process to keep the materialized view up to date, but it take 1 minute to refresh. Okay, there is a 1 minute latency. We call it as latency difference, time difference between the actual table and the materialized view. Okay, and here there is a thumb rule. Okay, do not use materialized view if whenever the data changes frequently. Now what will happen? Okay, just to check whether is there any changes happen on the base table or not. Okay, if this table, every time you are adding new data, if you are updating new data, right? Okay, now I need a VM. Okay, I need a VM here to check and process these changes into the materialized view. So I need to run this VM continuously, which will cost so much. Okay,
Mm.
that is the reason we will not create materialized view on frequently changing tables. Okay, next. Improve the performance, no need of additional maintenance, auto refresh of result, data access through materialized view, it's regret, DML that has been performed on the base table. Whenever there is a DML changes happen, those will be reflected here. Okay, so in the Snowflake, when we use this materialized view means we have three main reasons. First is rather than using external table, okay, what we do, we create materialized view on top of this external table. Okay, I will tell you what is external table in the later classes. In simple terms, okay, I have a file, okay, to call the data as a table in Snowflake, we use this external table. Okay, so if I want to write some complex logics on this sectional table, it takes a lot of VM cost. Rather than writing that one, what I do, I'll create a materialized view, which means whatever the data is there in the external table, that will be loaded into the materialized view, and I will write complex logic on the materialized view rather than external table. Okay, select performance on large tables by creating clustered materialized view, complex query which changes very infrequently. So I'll tell you what is this clustered view in the later classes. Okay, next, aggregations. So to store the aggregate results, okay, every time if I'm getting data, see, assume there is a table product. If I'm doing aggregation, I need a large VM, right? So every time I'm using this large VM, so I'm going to charge around 10 to 20 credits daily. So rather than that one, what I do, I'll create a materialized view on top of this table. Okay, now what will happen? So to store this result, it take 1 credit. Okay, now second time onwards, I don't require any large VM because this result is already stored. I use extra small, so very extra small to process this one. So rather than paying 10 credits, here I'm going to pay 2 or 3 credits. Okay. Next, third one. So multi-cluster option needed, long-running aggregation, semi-structured data. So these are the three reasons where I create materialized view. Okay, so the query result from view does not change oftenly. The result of the view often, the query consumes a lot of resource. Create regular view when result of view changes oftenly. When our results changes happen oftenly, then we need to go with the view. Query is simple, contain multiple tables. Okay, limitation of materialized view. Okay, so you cannot create materialized view on top of functions. You cannot use functions, limit, order by, all those things. These all not will support in the materialized view. So here storage cost is involved, compute cost is involved for creating and processing the materialized view. So that's it about materialized view.
Okay, here by using that view, updates are insert like deletion is possible.
Where in the materialized view?
Uh,
No, no, we cannot update or delete. Okay, when our base table data changes happen,
hmm.
with the help of VM, it will load the same data into the materialized view.
Might be in the normal view it's possible, right? Only by using the
Normal
single.
view also you cannot insert or update. Okay, so it's just storing the query. It's not storing the data.
Hmm.
So it's like see, simple. Why we use views and materialized view? First of all, doing transformation. See, I want to load all this data into some Postgres database. I'll go with the view. Okay. So for using data marts, okay, I go with the materialized view. Okay, what is data mart? Okay. So assume this is a Snowflake. I have a three layers. So most of the projects will look like this only. One is bronze, silver, and then there is a gold layer. Okay. This gold layer, what I do, I will load multiple data, multiple table data into single table. Okay, this we call it as a denormalization. Okay. Now, now here, if I create a table, now what will happen? I need to wait until the next day to reflect the data. See, now I have see. So there is a batch job which will run morning 9 o'clock. Now the data morning 9 o'clock, the data will move from here to here. Okay, and then here to here. Now 11 due to some business inputs, so new data has added at 11 o'clock. Okay, is this data is going to reflect here? No, I need to wait for next day run, right? Rather
Yeah.
than creating table here, what I'll do, I'll create materialized view. Now if any changes happen here, that will be reflected in this materialized view. Clear? Any doubts?
Mm-hmm. Understood.
So if I create a table, I need to wait for next run. If I create materialized view, it will load the data automatically. And here, so I have mentioned three reasons. One is if this table is external table, which means here I'm getting data from files outside the Snowflake, then to apply some what we call aggregation on top of this external table, it takes a lot of compute cost. Rather than that one, what I do, I'll create a materialized view on top of this external table. Now, so the file will not change, the data will not change, and this materialized view will have the data. So clustering, so I cannot cluster each time, right? So every query I cannot create a clustering. So I'll tell you what is clustering later. So I cannot create multiple clusters on a single table. So rather than that one, I'll create multiple materialized view tables and I create cluster keys on that materialized view. Okay, that I'll explain it later, what is cluster key and all those things. So like that, okay, to do multiple join conditions, I go with view. To create a data mart, okay, I go with the materialized view. Simple.
Okay, here is that primary key won't be support, right? How like creating the clusters?
Primary, no, no. It see whenever I create a table, right, a partition will happen.
Mm-hmm.
Okay, so it will select that particular column how to store the data rather than giving the option to Snowflake. What I write, I'll create a cluster key. Okay, that I'll explain later.
Okay.
So it is completely different concept. Here we go with the partitioning concept. So when it comes to
Mm.
partitioning, so we need to provide them a cluster key. So on which column we need to divide the files or create the files.
Okay, mostly creating partition basis upon the dates or something, right?
Yes.
Okay.
Mhm. Somewhere I lost the file. Okay. Let me go with materialized view. Create materialized view. So mv prod as select star from products. Now what will happen? Unexpected MV product.
No,
Spelling.
no, spelling wrong.
Okay. Now what will happen if I call this table? First time it will trigger this underlying query, and it whatever the data I will get, right, it will be loaded into this materializer view. So if I execute the second time onwards, it will be fast because it is extracting the data from MV, not from the underlying query. Okay. Now whenever the changes happen in here, right, in the product table, it takes 1 minute to load it into this materializer view. There will be latency of 1 minute here. Now the second point is, okay, the second point is you cannot create materializer view on multiple tables. Let me take this one.
Not support the Windows and aggregation functions, right?
Yeah, it support. Let me go one by one where I have created. Mhm. Okay, let me put a dot star. Okay, cross join sales B. Okay, now you can see it will throw the error because we cannot create materialized view on multiple tables. Let me put create or replace. Invalid materialized view. More than one table referenced in the view definition. Next. So next point, when it comes to next point, so you cannot use functions like created it, which is a dynamic, right? So dynamic, we cannot use it here as created it. It will throw the error. So you cannot use these functions, created at functions, this new what we call this date functions in the materializer view. And this is the second point. Coming to the third point, you cannot use having in the select query. You cannot use having in the select query like that. So there is a lot of restrictions for creating a materializer view. Those I already highlighted here. Okay. So yeah, this one highlighted. Materialized view cannot have another you cannot create a materialized view on top of another materialized view or non-materialized view. User defined tables. Non-materialized view means normal and secure views. Okay. User defined tables, external functions, Windows functions, order by, limit, group by columns that are not within the select list. And then having, then group by group sets, roll up, cube, subqueries. So you cannot in this minus, except and intersect, these three things will not work. Okay, only for the union all only. This material you can create this materialized view on top of union and union all. You cannot create on except and intersect operators. Okay, these are the limitations that we have related to materialized view. So any doubts up to here? So let me go with the data warehousing concepts. Okay, I have divided this section into two parts, okay, for better understanding. This is very important when it comes to architecture level and interview point of view. Okay. So what exactly data engineer will do? Okay. So data engineer responsibility is like either he may work on cloud or on premises. Okay. First he need to create a database and he create a pipelines with the help of ETL tool until it reaches to the data analyst. So this is what exactly the data engineer will do in the real time scenario. Okay. Next. So we'll go with one example. So what exactly as a data engineer we are doing, how the outer world is working. Okay, I'll go with one example. Okay, assume this Amazon is started in 1994. Okay, so in the span of 15 years, what happened? Okay, this Amazon guy, so he increased the what we call this velocity. Like he put it so many teams, like a few employees are using Power BI, Tableau, ClickSense. So he introduced mobile apps. So all the customers are moved to the mobile apps. Few customers are using web portal. Like that, so the variety of the velocity of what we call what we call this OS operating systems has increased. Next, now previously it's worked only for the US. Now increased all over the world. Now previously the records will be 1 lakh or 2 lakhs daily. Now if he increase the business all over the world, now he started getting around 10 crores records into the database. Okay, and he has a tie up with multiple vendors. Okay, each vendor will provide data in multiple formats. Few vendor will share this product details in CSV, few will share in Java, JSON, few will share in XML, Avro, Parquet. So varieties of files also getting increases. So in the 15-year span, so due to increasing the number of locations, business location volume got increased. Having multiple vendors, each vendor is providing data in multiple formats, variety of getting data increased due to using multiple operating systems like mobile app, desktops, these all the Power BI, Tableau, velocity of the data increase. Due to these three V's, okay, this MySQL database is not able to handle, it start hunks, okay, as it is a big data. Now this application need a big data fixes, okay, as this is a big data application, now it became big data application. Now this Amazon guy has contacted, assume he contacted some company called Deloitte or something, okay, he asked for a plan how to I want to continue this business with very smooth. I don't want to get the database down and all those things. Then these guys suggested, okay, so you need to divide the existing database into two databases. Okay, what he suggested, we need to divide the existing database into two databases, two or more databases. One is the existing MySQL, we keep as it is. This we call it as OLTP, which means online transaction processing. Another one, we will create one more new database, that is data warehouse. We call it as OLAP. Okay. Now, how to choose? Now, to put this OLTP and OLAP, like, see, if I want to, how to choose the database? See, I have multiple databases are available in the market, right? Like MySQL, MS SQL, Oracle, Postgres, Redshift, BigQuery, Snowflake, Synapse. So, how to choose the database for OLTP and how to choose the OLAP? Very simple. So, that database, whatever the database you are choosing, if the database is storing the data in the form of row format, that we will select it for the OLTP. Okay, what are the database storing the data in the form of row format, that we choose it for the OLTP. Whatever the database that is storing the data in the columnar format, okay, that we choose it for the data warehouse. Clear? Any doubts here? Okay, now every day what we do, okay, we will load all the data from OLTP to OLAP and I will truncate this data. So every day this database will be fresh, because so to do insertion, the data table should be empty. Then only I can do insertion very quickly. Okay, so that is the reason in the OLTP this constraints topic will be there. Okay, I can create primary key, foreign key, all those things, because it has the limited data or current data, right? So there will be no much impact. But when it comes to OLAP, if you create this primary key, all those things, it will be very hectic. Okay, so this OLTP, how we choose the database, whatever the database that is storing the data in the row format, that we choose as a OLTP. How we choose the OLAP, whatever the database that is storing the data in a columnar format, that we choose as a OLAP. Now, what are the benefits of row-based storage and column-based storage? So if you take this row-based storage, insertion of the data is very easy. So insertion of data is very easy. I can insert the records quickly, because so I mean, whatever the data I'm inserting, that is stored as it is. But here in the OLAP, the insertion will be hard. Why? Now assume this is a micro partition. Now it need to check. Okay, first what it need to do? It need to analyze that particular records, and it need to place ID column in this block, name column in this block, phone number column in this block. It need to arrange these records. That is the reason in the OLAP insertion will take a lot of time. Okay, but when it comes to reporting, right? So reporting, so here it is hard to create a report on top of this OLTP. That is the reason we will not generate any reports on top of OLTP, because Even though I need only this one customer detail, I need to scan all these files. Okay, I just need a customer ID. For customer ID, I need to scan all these files. When it comes to here, I need to just scan this one block. I don't need to scan all these other blocks. So that is the reason. When it comes to reporting side, I use this OLAP. When it comes to insertion, I will use OLTP. Clear? Any doubts? Now, who is going to do this doing this data transformation? So here, one big guy come into the picture. That is ETL tool. So we have multiple ETL tools available in the market. So we use this ETL tool for doing these data transformations. Clear? Any doubts? Okay. So to process structured data, okay, I may have OLTP, I may have files. With the help of this ETL, I will load everything into the data warehouse. Okay. As highlighted before, this data warehouse will have historical data. If you take any banking application, you can extract 1 month transaction report. You cannot extract 1 year or 2 years of reports because this data is not extracting from data warehouse. It is extracting from the data mart. So why we use data mart? To make the reporting fast, what I do, I will load only active records or current month details into this data mart. So now I'll generate the reports on top of the data mart, not from the data warehouse. So that is the reason if you apply for 1 year, right, you need to raise a request. Now that banking guy will connect to the data warehouse or for the 1 year data. So for current month data or last 10 transaction will be stored in the data mart. Clear? Any doubts? Because
No,
Sainath, Nihal.
no problem.
No, sir. No.
Okay. Next, this is for only structured data. If you want to process unstructured data, right? Or semi-structured data, what we use data lake. Okay. So data lake, most of the times we, as a Snowflake developer, we work with cloud, right? So as highlighted before, AWS will have S3, Azure will have blob storage, GCS will have Google Cloud Storage. We will place all these files into this data lake. Okay. Now, if I want to process this unstructured data or semi-structured data, I use this Hadoop clusters. Okay. So for example, if you take Google app, okay, so open Google app, take a camera, okay, take a tomato picture or any vegetables or fruit picture. What will happen? So it will raise this Hadoop cluster. It will check where this image is matching in the existing data lake. So if it is matches with the tomato folder, so it will go to Snowflake or some MongoDB, okay, wherever that tomato name is matching with the what we call data, that data will be printed in your query. Nothing but you will get a search history, right? So this is what how it process the unstructured data. Okay. So any doubts for you about the structured and unstructured data? Okay, so this we call it as a raw data. Whatever the data available in the OLTP and the files, we call it as a raw data. So raw data originally unrefined data gathered from source before processing or analysis. Okay, so how we will get the raw data from multiple databases, from web, from mobile app, from other applications or API or multiple files also. This is how we'll get the raw data. So nowadays we are getting the data from IoT devices on the applications as well. Okay. Now after getting the raw data, who is going to do the transformations? This ETL guy will do the transformations. Here we have few steps to do ETL. Okay. For extraction, we have few steps, full extraction, incremental extractions, methods, and there is a techniques to the extraction. And then we do the transformations, nothing but data cleaning, removing unwanted duplicate records, replacing null value with another null value. All these things we call it as a data cleaning. Okay. Then we will load it into the data warehouse. Okay. So now in the market, I can do with the help of ETL tool, I can do two things. Either I can do ETL or I can do ELT. Okay. When we use ETL and when we use ELT. Okay. Let me go with the paint. Okay. If I'm going with the on-premises server, okay, this on-premises server will have a limitation, right? So if I take 32 GB RAM, and 1 TB hard disk. Now in the span of 1 year, now I got 1.1 TB data. Now I cannot store in the here, right? 1.1 TB data. I cannot store because my storage capacity is 1 TB. That is the reason while loading the data into this on premises, what I do ETL, which means first I'll connect with this source system. Okay, first I'll connect with this source system. I will do the transformations because here my storage is limited. That is the reason I will load only limited records, which means active records, removing duplicates. I will do the transformation and I will store a lot of space. Then only I will load the data into the data warehouse. So in on-premises, we go with ETL. If you take cloud, here the storage is cheap. That is the reason what we do, we use which means which means whatever the data we are extracting, right, that will be loaded into the data warehouse, nothing but the cloud environment. Okay. Now here computing cost is very cost. Here it's free. Say I can use whatever the query I'm processing, it will be processed within the 32 GB, which is free. But when it comes to Snowflake, so I need to pay for every query, right? If I want to process the query, I need to pay everything. That is the reason. Okay. In the silver layer, this is a bronze. This in the silver layer, we load whatever the data we require, limited records will be processed and that will be transformed. So here storage is cost cheap, that is the reason we are extracting and loading, and here computing is cost, that is the reason we process only limited we do the transformations only on limited records because I need to pay for computing. So that is the difference between ETL and ELT. If you go with the on-premises, you do ETL. Okay, if you go with the cloud, you go with the ELT because here storage is cheap, transformation is cost. Here transformation is cheap, storage is costlier. Clear? So difference between ETL and ELT when we are going to do ETL and when we are going to do ELT, you are clear, right? Okay, these are the ETL tools
Yeah,
available in the market.
mostly using in the cloud level ELT.
Yeah, ELT because storage is cheap, right? Whatever the data I'll get, I'll store it in the ELT. Load it, extract and directly load it into the data warehouse. I'll not do any cleaning. Okay. So we have multiple ELT tools available in the market. Okay. And if you take cloud has some their own ETL tools like the here we have data flow like that, and this will be scheduled. Okay, this orchestration will be taken care. If you take ADF, Azure, it will be taken care by ADF. If you take this AWS and GCP, it will going to taken care by Airflow. Okay, these are orchestration tools to move the data from one place to one place. Okay, దీంట్లో మనం షెడ్యూల్ చేస్తాం. We'll schedule in this ETL tool at what time the data need to be processed. So based on the schedule time, this orchestration tool will trigger the procedures and scripts, and it will move data from one place to another place. Clear? Any doubts? Up to here, any doubts?
No,
Okay.
sir.
Yeah. So in the real-time scenario, we use multiple databases. Not only these databases, we use multiple databases. For storing the structured data, okay, business information, we go with the RDBMS, which means Relation Database Management System. Okay, here what is RDBMS? We create database and we'll store the data in multiple tables and we create a relation between them. So this we use for storing business information. To store the logs, okay, feed information, I go with the NoSQL because if I want to retrieve some record from the RDBMS, it takes some time. It need to process the records, right? But when it comes to NoSQL, here the data will be stored in the form of document. So here the pattern matching will be happen. That is the reason you will get an instant result. Okay. So if you want to print get the feed details, log information, all those things we use NoSQL. Okay. Now we have other DBs like time serial search based DBs for this thing. Okay. So I'll tell you where it will be applicable. I'll go with the LinkedIn example. Let me open my LinkedIn profile. Okay, so LinkedIn will use multiple databases. Okay, what are the information it will store and how it will be stored? I'll tell you. If you go to my profile, all my images, title, this description, my company details, everything will be stored in the RDBMS. That is the reason it is taking time to load it here. Okay, but if you go to my feed page, right, it will be loaded within a seconds. Why? These details we are getting it from the NoSQL database. So NoSQL database is very useful to fetch the quick result. Next, we have time serial database, which means whenever I get notification, right, that will be reflected here. How? Because here we are using time serial database. Whenever the data changes happen in the table, that will be reflected directly in the here. Though that is the benefits of time serial database. 1 minute. Yeah, sorry. Yeah, that's it about this multiple database we use in the real time. So as highlighted before, we have row-based storage, columnar-based storage, column-based storage. 1 minute, I'll put my charging. Okay, so yeah, so that's it about OLTP and OLAP. And you need to learn as a data engineer, you need to learn SQL as well as Python. I'll tell you what is the reason behind this learning Python. So overall, that's it. Okay. Now, if you take this data warehouse, we have three layers. Okay. One is sorry. So we'll go with this what we called architecture related to Netflix. So you all know, right? Application will have front end, back end, and database. Here, the front end will be JavaScript, back end will be Java. If you see here they are using MySQL as a OLTP database, and Amazon, what we call Amazon Redshift as a OLAP. Okay, and they are using S3 as a data lake. Clear. On top of this thing, they use these BI tools and this data, what we call AML tools for processing the data. Okay. So in the real-time scenario, most of the companies will use PySpark or Snowpark. Okay, depends based on the client requirement. They may use some third party to process the data from multiple source system into the Snowflake. For instant streaming data, we use this Kafka and Flink in the real time. Okay, even though Snowflake has its own ETL tool and own Snowpipe, those are not much compatible with these third-party tools. Clear? Any doubts? ఏదైనా డౌట్ ఉందా?
No, sir.
Okay, we'll take a break here. Tomorrow we'll connect for the other topics.
So, sir, can we get this PDFs?
Okay, so again I'm sharing. I already shared. I'll share with you also again. So there is a document called 2026. Okay. Okay, these documents you can find all the PPTs, the queries I'm executing, everything will be available here.
Okay.
I'm sharing again here in the chat. Okay, just whatever the PPTs I'm explaining, everything will be available here.
Mm.
Here you can find this data concept 1 and 2. Okay. Thanks all. We'll connect tomorrow. We'll discuss this now what we call the SCD types, and then tomorrow we'll take a break. Okay. So thanks all. Bye.
Yeah, thank you. Thank you, sir.